Hello, everybody. Good morning to all. Welcome to this sixth ETP4HPC webinar on artificial intelligence. Um, I'm Pascal. I'm the ETP4HPC communication manager, but I'm not alone. Today, I have colleagues to help running the show. Maike here, you can see her, will take care of the chat. She's the one who has been chatting to you already. And Michael Malms is here as well, and he will moderate the questions. So a few words about logistics before we start. This webinar is recorded, and you will receive the link to the recording tomorrow. This webinar is in listen-only mode, so don't be surprised if you can't switch on your mic. But you can't talk, but you can ask questions in the question panel. You can ask questions at any time, or you can send your remarks in the question panel as well. Anytime during the session, submit your question, and we will either answer it online during the presentation, or we will keep it for the end when we have our final question Q&A session. What you can also do is download the handouts. All presentations are available today as handouts. You can download them. If you should have it either above or below your question panel. And I have put also today in the handouts the Transcontinuum Initiative document, the vision document, and the associated press release that was published a couple of days ago. Those documents were produced by ETP4HPC and Claire, our main guest today, with 6 other associations. So let's display our agenda. So for those of you who are not familiar with ETP4HPC, sorry, I was checking a technical point and I got lost in my panels. So for those of you who are not familiar with ETP4HPC, I will introduce our association very briefly. ETP4HPC is a non-profit association that promotes European research and innovation in HPC. We are a private member of the EuroHPC JU. That's the organization in the European Commission that addresses HPC. And our main mission is to advise on research priorities for Europe in the area of HPC, of course. So now I think you can see all of our speakers. Yes, Andy, Philip, Yanis, you're all here. So today's main topic is artificial intelligence, a domain which is very close to HPC. And for that, we have invited Philip Sluzelek from Claire. So as I said, it's an organization we collaborate with within the Transcontinuum initiative. But before that, we will have our usual new members session. So today we welcome 2 new members to organizations that joined ETP4HPC recently, and they are SMEs, which is not unusual because more than a third of our members are SMEs. So today we will welcome Exapsys, Exascale Performance Systems. It's a Greek SME. They are joining as an associated member, and they will be represented by Yanis Papaestatiu. And our second new member is Andy Forrester from Hype Accelerator Solutions. They are a an SME based in the UK, and they are joining as an associated member as well. So first, we'll have Yanis. Yanis, are you ready?
Yes, sure.
The floor is yours. Just tell me when I need to switch the slides.
Sure. Thank you very much. So Exapsys is a really young company. We're just a year old. We were founded last December, and we are focusing obviously on HPC. So can you please move to the next slide? Can you move to the next slide, please?
Yeah, I did, but it's slow.
Oh, okay, sorry. Okay, so we're a spin-off of actually 3 different organizations. So we started from 2 research institutions in Greece. One is Forth, you have probably heard of it. They are really active in HPC. And the other one is Telecommunication Systems Institute, which is a smaller one, and they are more active, obviously, in telecommunications, as you can understand from the name. But they have a really good activity in HPC as well. And there is an SME called Synalixis, which has designed quite a few systems within the HPC area, and we got all those results, and we created, as well as the team, to be honest, and we created Exapsys. So the main 2 things, though, that we are focusing on, if you look at our inventory, we have quite a lot of things to develop that we have developed as part of the research institution and the SME. But as Exapsys, we do focus in 2 different things, and one of them is a novel simulator that we have, which can simulate virtually tens of thousands of CPUs together with our memories, the networks, and all the associated peripherals under one roof. So you do have one simulator, and you can have any kind of network that you can imagine, and you can simulate it, and you can also run a full system together with the operating system and the application on whatever CPU you select, and they have the same notion of time and so on. So it is indeed something that we have used quite extensively, and it seems that it scales very well as well, and it seems that it's a very promising approach. And the second one is what you can see on the right, which is a reference HPC prototype, which has tens of to hundreds of interconnected FPGAs. It has different intercommunication paradigms, and you can run any multi-FPGA accelerator that you want over there. And we have our custom very low latency, high bandwidth FPGA to FPGA intercommunication. Obviously, on the top of this machine, we have also developed a couple of FPGA accelerators for our own purposes, and we have proved that those machines can be really efficient in certain applications. Can we move to the next slide, please? And so who we are, as I mentioned, we took the IP from those research institutions and the SME, and we are also the same team that have developed all those things that you have seen there. Obviously, the machine that you saw before is part of a NEU project, so it was a common effort. It has not been developed by us, but we do have full access to it since it belongs to one of the research institutions that I mentioned before, to Forth, and we have an agreement with them. So we provide this full access, and as far as we know, this is the only working prototype in HPC which contains hundreds of interconnected FPGAs. There is another project, and we are part of it, which will develop a larger and better testbed, but for the time being, this is the best that you can get, I guess, if you want to run your FPGA accelerator or you want to try this new technology. If you combine, we are 3 founders actually, and we have more than 30 years of experience in high-end FPGA design and more than 15 years of experience in both design and parallel simulation tools. And I believe this is a kind of asset that help us went quite well. And if we move to the next slide, please. That is the.
Sorry, it's very, yeah, now.
Sure, yeah, thanks. That is the thing that I mentioned, that based on the experience of the team and the IP that we have, we are now part of 4 running 2020 HPC projects, and over there we contribute with our simulator, and we develop some FPGA-based accelerators as well. and actually in one of them we are technically coordinating one of them, and the main topic of it is to have different, mainly SMEs, but a couple of large companies as well, to use this FPGA-based HPC system so as to see whether it is efficient in different applications. Now, what we are looking for, well, we have this novel simulator and we have tested it within the systems that we have developed, but we are certainly looking for new customers, and we're certainly looking for new cooperations. So we're looking for HPC integrators that they want to use the simulator so as to simulate the systems that are about to build. And this also applies to HPC centers that they would probably like to test what or play with what they would like to invest their money on. And if you have any demanding HPC applications, we will be more than glad to implement and help you with implementing tailor-made FPGA accelerators that can make your life better. And that's basically it from my side. We have the last slide where there are my contact details.
It's coming. Sorry, it's extremely slow today.
Okay, so this is our website, this is my email, and I would be more than glad to talk to any of you. Thanks a lot.
Thank you, Yanis. Thank you. We're very happy to have you. And so if any of you has is interested in what Exapsys is doing, if you have ideas for a collaboration, now you know you can contact Yanis. So our next speaker is Hpaccelerator. Now, yeah, here is the slide. Hello, Andy.
Good morning,
Welcome.
everybody. Thank you very much. Thanks very much, Pascal. That's our introductory slide. I'm here in the flesh, and I'm talking to you from Brighton, and specifically the University of Sussex Research, Innovation and Technology Exchange. Can we have the first proper slide, please, Pascal?
It's on its way.
Great, thank you. So, 5 minutes on what we do and who we are. So we are a micro consultancy. There's 6 of us, and as the banner states in blue, we use accelerated disruptive thinking across those 5 disciplines you see below to create innovative ideas, solutions, and strategies. So the vast, significant proportion of our work is in supercomputing. I myself I regard myself as a technical architect, and we are currently involved in some significant hyperscale data center design and build projects, and the bulk of our work is in the realm of AI and machine learning, high performance data analytics. We also advise on technology trend mapping, and that's effectively looking into the future and next generation architectures. And we also support our major clients with infrastructure road mapping strategies and transformation projects. Could I have the next slide, please, Pascal? So, who we are? Well, there's our mission statement. We are here to implement solutions for our clients, not just for today's business needs. And when I talk about business, I'm talking about the business of technology overall, but to incorporate our customers' future strategies and plans for growth. So, Hpaccelerator was originally founded in July 2005. And specifically supporting the oil and gas sector. And it was while working in the oil and gas sector that I was introduced to high throughput computing, and we then went on to specialize in technology at scale, high performance computing, high throughput computing. So there are 6 of us. We are a team of strategists, technical architects, software engineers, and futurists. I don't necessarily specialise. I call myself a jack of all trades, but master of none across those disciplines. We deliver programs and complex projects for our clients, and our clients come from government, the technology integrators, the financial sector, and science. I want to highlight the work we did with the European Commission and DG Connect last year, when we were consultants delivering a technical assessment and evaluation of Euro HPC for DG Connect. And that is how I got introduced to ETP4HPC. And then finally, we are strategic partners to multidisciplinary design teams for hyperscale facilities, and we offer up our expertise to big multidisciplinary consultancies, particularly advising on high performance computing, high throughput computing, and specifically mechanical, electrical, and power designs. So that concludes my presentation. Can I have the last slide, please, Pascal? So rather than take any questions through the webinar, my contact details are down there on the left-hand side. Do feel free to reach out to me by email, on the phone, or through Twitter. So that concludes my presentation. Thanks very much, Pascal.
Thank you very much, Andy, and thank you, Yanis. It was lovely to have you both. So again, if you have an idea for a collaboration with Hyperaccelerator or with Exapsys, now you know how to reach them. Thank you very much. So we'll move on to today's focus subject. So I will allow Philip to share his slides. So now you should be able to show your screen, Philip. Okay. Yeah. Excellent. We can't hear you.
Yep. Now hopefully you do.
Yes, we do. We're all set then.
Sorry, I was still muted. Okay. Thank you very much for the introduction. And to switch to the slides again. Yes, so thanks for the possibility to introduce Claire a little bit and talk a little bit about AI, specifically AI research in Europe. I've structured my talk such that I'll talk a little bit about our background, where I come from. I'm one of the co-founders of Claire. I'll talk, Michael asked me a little bit to talk about AI, how we understand AI, and then specifically focus on Claire, the organization, the Confederation for Labs for AI Research in Europe, which is actually the largest AI research, the largest AI community or organization worldwide. Myself, I'm a professor for computer graphics at Saarland University, right on the French border in Germany. And I'm a scientific director at the German Research Center for Artificial Intelligence. The DFKI, the German Research Center for Artificial Intelligence, is actually the largest independent research center for AI worldwide, 32 years old, so we've been around for a while. We have 6 sites in Germany, actually 21 research areas, several competence centers, 1,100 people, lots of spin-offs and lots of funding and lots of increasing funding. We're actually a private-public partnership with many companies. You see Microsoft, Google, Intel, NVIDIA, the car industry, many others, financial industry, agriculture industry, many others. And we have these 6 sites across Germany, and we'll actually in the process of adding a few more to that. So I'll go through that quickly because it's just a little bit of background. My own work area is in what we call trusted AI. consisting of developing AI systems that can provide guarantees, and I'll come back to that. And through those guarantees, enable us to make the AI system understandable to human, and thus enable trusting the AI systems. One of the processes that we do this is digital reality, where we, through simulations, large-scale simulations, we generate synthetic data, which we then use for training, validating, and most specifically also certifying AI systems. And all of this on large platforms, HPC platforms, in a reliable and in an efficient way. So we've done large multi-agent systems that, for instance, run an entire steel mill for many years now. We've done a lot of simulation for real-time ray tracing, which we started off. 2/3 of the Embry team at Intel come from my lab. I was personally involved when NVIDIA started their ray tracing activities, and many other companies are doing real-time ray tracing. We actually developed the first ray tracing. We heard about FPGAs. We had the first full ray tracing GPU, if you want. We called this the Ray Processing Unit. It was a paper at SIGGRAPH 2005. And as you know, ray tracing is now in the latest NVIDIA graphics cards and will be in AMD and Intel graphics cards going forward. And we're doing a lot of sensor simulation stuff, and this will become relevant in other contexts. And also, we're doing a lot of work on the compiler side. There's a paper at SIGGRAPH from this year where we developed a compiler that from the same source code, we can drive CPUs, GPUs, and we're working on FPGA actually from the same high-level program. And not just the same program, but we're actually beating hand-optimized codes on each one of those platforms, which, or at least we come close to, or in many cases actually beat this. So this is pretty exciting research, and I believe also specifically in the HPC community. Michael asked me to talk a little bit of how we understand artificial intelligence, so I'll spend a few minutes on this. First of all, it's important to note that intelligence is actually hard to define. The most common interpretation is probably something like the ability and inclination to perceive the world around us, to deduce information from that, to retain this in some way as knowledge, and then to apply that in different environments in an adaptive way. And so solve problems by essentially translating from experience we had in probably other environments into new environments. And on the AI side, intelligence is one definition is really just the same thing done by machines, or machines mimicking cognitive function, where one of the questions is, what does mimicking actually means? Is that are they doing the same thing? Is this actually something different? Or I would actually say AI is really the study of intelligent autonomous agents or systems, right? And if you keep this in mind, it makes a lot of sense, because if you, for instance, look at how AI is defined, there's this key elements of AI systems in this, what's often used as a see, think, act paradigm, consists of the following key pieces. The one is perception, right? This is essentially finding out what the world around looks like. This could also be digital sources, could be cameras, any sort of sensors. Then using machine learning, and there's a lot of deep learning there, but not only, to automatically build and adapt models of what is around this based on the perception data that we're getting. And then processing this in such a way that we can represent this knowledge, we can process this knowledge and communicate this model either to other systems, or also communicate with a human about that knowledge. Really interesting part. Once we have that knowledge, we want to then reason about this knowledge. We want to put our current perceptual data in context with what we know about the world, infer information based on that, and then use this combined information to plan the future actions. And that might involve actually simulating what we expect would happen if we would perform a certain action in this world, right? Because that might cause a reaction in the virtual world, and that is essentially how we work as humans, right? We want to explore possible options, evaluate their performance, and then use this combined information to make decisions about what is the best option. Of course, then we need to actually implement that, manipulate the world, make decisions, and act. And then we start all of this over. And of course, there's a lot of supporting functionality and application. Now, the interesting part that's often being discussed in this context is what actually is data science or data analytics in this environment. And I would really argue that data science and data analysis is really just the first part of this AI pipeline. Up to maybe knowledge representation, but often it's really just building some high-level models out of perception data. In some sense, making sense of that. But things become much more interesting if you add more of that AI pipeline to it, I would say. The other thing I want to say about AI is that AI is really a very broad area of technologies that you can roughly divide up into two areas, namely reasoning, that's symbolic computation, from early rule-based systems to statistical reasoning, many others. There's dozens of techniques that are available, dozens of tools essentially. And then there is the machine learning or learning area, which ranges from things like reinforcement learning, support vector machines, and other dozens of techniques, including deep learning. One of the problems we see today is that AI is often reduced to, oh, it's just deep learning. It's certainly not true. Deep learning is a really powerful technology, but AI consists of much more. And even the people who do a lot of deep learning today are starting to do more and more work of combining deep learning with other AI technologies and tools. Just very quickly, some of the big successes of AI, actually verification, hardware verification, has been a key technology developed in the AI community. It's pretty much a separate community now, but certainly originated in AI. And right, you haven't heard about big errors like the div bug in Intel, and that is because hardware is verified in large parts today. Even though our hardware complexity is dramatically bigger than it was back then. Knowledge graphs, right? We can really represent huge amounts of data and facts about the world, and up to 100 billion facts and rules. And reasoning about these large data is a bit more complicated, but even we can do a lot of reasoning of large parts of that knowledge already today, and this is where a lot of research is happening. Search and optimization, right? You know that we solved chess quite a number of years ago, and if you look at the search space, the size of the search space in chess, right, we're in 10 to the 20 or 40, which is pretty big already. But a lot of people thought that Go, which has a dramatically larger search space, it wouldn't be solved for a long time. And it's actually the combination of supervised machine learning, deep learning actually, plus reinforcement learning, plus Monte Carlo search, put together in the right way that allowed us to search even these huge spaces. But not everything is rosy in AI, right? So we're really capable of looking at the world like here, symbolically in this image here, and identify what's out there and what's going on, right? That's great. Right? But on the other hand, even a few colored patches on a stop sign make an AI believe it's something completely different, and a little bit of noise on a panda image can make you think it's anything else. Right? So that's obviously causing issues. And so I want to talk briefly about one technique that is very close to HPC that promises to solve at least part of that. And we call this digital reality. And I use autonomous driving as an example for that. You might have seen this image. This is the photo that was taken, the video that was taken from this person that was crossed a 7-lane road, and on the last lane was actually seen by the Uber car for almost 6 seconds, but the car decided not to do anything. It hit the woman who died. So obviously, the car could drive pretty well, right? It was actually not too bad in driving. So functionality is not enough, but we need the ability to certify, to guarantee what its capabilities are and where it stops working, right? And we need to be able to do this according to well-defined standards, so we can actually talk about and compare different AI systems. And a lot of that is simply not possible today. And why is this? Well, our world is extremely complex in terms of geometry, of how objects appear, how they move, how objects move, about weather. And even due to this extreme complexity, an AI system must reliably make a correct decision, even in critical situations. And I usually use a kid running in front of a car, right? Deep learning, as you know, needs a lot of data. But luckily, about kids being hit by a car, we don't have much data, and we don't want data, right? So this idea of how many million of miles do you have to drive until our cars are safe for autonomous driving is a completely stupid idea, because it essentially would translate to how long do I have to drive until I've hit enough kids such that I have enough information to learn and to avoid this situation in the future. And obviously, I think we all agree this is probably the wrong way of training our AI systems, okay? And so the idea is, can't we do this with synthetic data through simulation of models about how the world works? And so this is actually what we see how the industry currently is operating. So they've started, in autonomous driving, they've started training cars simply completely based on data that was captured from reality. But they've started to, and that's costly and doesn't scale, and I just talked about this problem. But the other part is they've started using simulations, and actually this digital reality that they're using there is, in many cases, actually using game engines, right? And so the question is, where does that data that's being simulated actually come from? And in many cases, it actually comes from artists who, for instance, animated pedestrians. And you can imagine that an animated pedestrian moves very differently than a real pedestrian, and there's a lot of detail that is missing there. So the question is, how good are these models, and can we actually learn everything from that? And the answer is pretty much no, it doesn't. It's not enough. It helps a little bit, but that doesn't scale. And so what we're proposing, and what one of the techniques that are being proposed here is what we call digital reality. It's this idea to use reality to learn models about the real world, and use these models to then model and put together, configure relevant scenarios, such as a kid running in front of a car. Then through various AI techniques and reasoning techniques, find out which of those scenarios are actually relevant or are critical, then instantiate these scenarios, so large kids, small kids, from left, from right, fast and slow, with snow and rain and whatever, right? And then doing lots of simulation. We need to, right, have hundreds, if not thousands, if not tens of thousands of these simulations, where we not only simulate the traffic scenario, but we also simulate the sensors of a car, such that we generate the data that a real car would see if it were in that situation. And then we can use that data for training of an AI system. We can use it to validate the AI system. Would the AI system actually do the right thing in that situation? And also for then certifying that, yes, this AI system does all the right things in the right situations. And then the last part is actually making sure that what we've learned here actually makes sense in the real world, but also to identify when maybe our models were not complete, or when reality changes over time, right? We of course need to adapt our models and maybe come up with new models too. So it's a continuous learning loop that's being done here. And while I explain this in the context of autonomous driving, none of that is specific to that application area. Actually, any AI system for which you can model the environment that the AI system interacts with is perfectly suitable for using this digital reality technology. And I hope you already see that, in particular, the right-hand side of this, but also the model learning parts require lots and lots of computation, lots and lots of simulation, and also reasoning about, which again is a lot of AI computation, reasoning about identifying which of those scenarios actually are relevant. So these are all areas where there's a lot of research now going on. So one of them, for example, and that actually has close links to many applications in scientific areas, to an area called auto AI, where you kind of automatically want to find the best possible configurations or the most relevant configuration, is identifying, characterizing, and sampling these extremely high-dimensional spaces. And there is a lot of information that I don't have time to go into, a lot of research in other areas, including, for instance, computer graphics, that tells us a lot about how we do this. So I hope you have at least a rough idea of what we're doing here in AI and some of the, and of course, this is only a very, very tiny bit of what we do in AI and how this links to high performance computing, right? And so this is why we as CLAIR actually are interested to collaborate much more with the HPC community. And the AI community was highly fragmented in Europe. And in mid of 2018, we decided we need to change that. We need to come up with, we need to bring together, if we want to have any chance against China and the US, we need to join forces and bring the AI community together in Europe. And so we founded the Confederation of Labs for AI Research in Europe in the mid of 2018. Our goals are excellence across all of AI for all of Europe with a human-centered focus. And so we aim at strengthening the excellence in research and innovation across all of AI, not just deep learning and not just learning, but all the combinations that I mentioned. Establish visibility and brand recognition for European AI, really important, right? Google, everyone knows Google is doing AI, which is not necessarily true for the excellent AI that we have in Europe. Develop an AI roadmap, and there are a lot of these transcontinuum initiative, and all of that is closely linked to that, and we hope we can provide good input to that. And of course, provide input and support to the European Commission, and also, and that's really important to us, also the national AI activities, and link them with what happens at the European level. Very roughly speaking, our vision has three main components. The one is, and we've mostly completed that, is create a research across all of Europe. We have a network of almost 400 AI labs across Europe that are members of CLAIR. They all have their specific areas of research that they're doing. So we've essentially covered. And that's important because we need this everywhere in Europe. We need to pick up the best talent wherever it grows up, but we also need to distribute any great AI technology to all the small and medium-sized companies across Europe. So only having a few centers in Europe is not enough. But we do need those centers, and so we also argue for regional centers of excellence. And actually, the ICT48, the 4 ICT48 networks that have been created are a step in that direction, but we think we can do more there. And the final step is we believe we need a European AI hub, which the Commission now calls, it's actually in the white paper of the Commission, it's called the Lighthouse Center there. I like to call it the CERN for AI, because everyone immediately, any politician immediately recognizes what CERN is, and building something like CERN, we believe, is really, really important, if not only for having a symbol for European excellence and ambition in AI, but also providing an infrastructure for large-scale AI research that is simply not possible in individual labs, but where we need to really bring the expertise together with the right infrastructure. And a big computing infrastructure is certainly part of this. Just some facts and figures about CLAIR, about 3,600 individual supporters, many of them AI experts, many of them with an industry background. a network of almost 400, I think it's 385 now, research groups. I mentioned that, with more than 20,000 employees being represented there. We're supported by the AAAI, which is the International AI Organization, the European one, all the national AI organizations. 9 European governments have written letters of support and partially fund us financially. We've established links to the European Space Agency. We're talking to CERN and various other parts. And you see the timeline a little bit. I don't have time to go through that, but we've been very, very active over the 2.5 years that CLAIR exists. Just very briefly, we're really everywhere in Europe. There certainly can be a few more people in some of those countries, but we cover essentially all the important stuff. We have a strong international advisory board, really top people in AI from all over the world, which we believe is really important to give us guidance. I don't have time to go through the CLAIR, how we organize, but very quickly, we have the 3 founders form the board. We have a core team, an extended core team with some top people from the European AI. We have a number of offices all across Europe now. We have a number of informal advisory groups who help us for specific areas of AI. The advisory board I mentioned, we have these national contact points, and we're building this academic network, which pretty much exists, and we're just starting to build an innovation network, which is essentially an industry network across all of Europe. We've started this, I have some more information on that. Probably the most important part that is relevant for this discussion are the ICT48 networks that have just started in September. CLAIR is the main organization behind 3 of those, Taylor, Humane AI Net, and AI for Media. There's the 4th one that is supported by Ellis. CLAIR is also strongly an initiator of the Vision, of the Vision project, which is the coordination and support action that will or has the mandate to actually bring together those 4 networks. Don't ask me why the EU wanted 4 networks. I think we need one big network for European AI, and we're trying to bring these 4 networks together such that they form a single network with the specific identities of each group of people, of course. So we're very strongly here, and this is maybe the best picture of how this all fits together. We have these 4 networks: AI for Media, Taylor, Humane AI Net, and Elise. We have CLAIR and EuroAI, which is on the organizational side. We have the EU Robotics BDVA, with whom we do a lot of the PPP for AI activities that are currently being discussed. We have strong links to the AI for You, which builds these European AI platform. And of course, industry and specifically the AI Digital Innovation Hub in Europe are key elements, which with the interface, and of course, there's much more than that. And so really mobilize the European AI community, strengthen these synergies is really what we're trying to do here. There's a little bit more information on each of these big networks. Each one has about 50 plus partners. 12 million for 50 partners is actually not that much money, but we expect that there will be a lot more money flowing, and the Commission has already said that there will be a lot more money kind of flowing into these different networks and extending those networks. Also, because of limitations in funding, of course, there's only some of the AI labs across Europe can actually be part of that. But there's already very strong links between them, and these are the ones that are close to CLAIR, and so that we also have very close links, and we're trying to establish even more links to Elise, which is driven in a different way. And yeah, I don't have time to go into that. We organize a lot of our work in task forces. So for instance, we had a task force for the response to the Commission's white paper on AI. So we organized providing feedback from the large CLAIR community. We did that compiled this down to 10 recommendations. We asked our community to provide additional input. That's one of the ways how we do this. And the really interesting part is that the EC white paper on AI that was released in February this year essentially embraced all of the key features of the original CLAIR vision that we formulated in mid-2018, including our AI hub, which they now call the Lighthouse Center for AI. We're working with, I mentioned this, BDVA, ELIS, AU Robotics, EurAI, and the Commission on forming a private-public partnership, European partnership, as I think they call it now. So this is high activity. As I mentioned, that we're now just starting off building a large industry network. We already have 50 industry partners that we're directly talking about now, really legally forming this industry network, which looks pretty great. There's a lot of interest from the industry. So let me conclude by saying how can, maybe if you're interested, how can you support and maybe get engaged in CLAIR? The most simple things you could do is join as an individual supporter. It's a 2-minute thing on our website, which is clair-ai.org. You and your lab, not individuals, but labs can become part of our research network. And industry partners can become part of our industry network, as I just mentioned. We have our own social media communication platform using Zulip, moving to Mattermost in the next weeks, that is available to all our members and supporters. And if you have any specific interests, like, so we have a special interest groups on various techniques, on various areas and industrial aspects. So we have these task forces. So if you want to be part of any of this, let us know. We're happy to talk. And we're talking to many organizations, including ETP4HPC, which is one of the reasons I'm here. And one of the things we're doing starting next year is a large number of what we call theme development workshops, which essentially brings industry of a certain sector together with all the relevant AI people that could contribute to this. And we've made great experience of these workshops, really essentially kicking off an entire research roadmap for space when we did this with ESA. In a single day, essentially, we identified all the key topics for the roadmap. Of course, that required a little bit of work afterwards, but I think this was a great way to kick things off, and we're doing this for many other sectors. So with this, I'm done, mostly in time, I guess, or almost.
Yes, perfectly on time.
Here's my contact information, and I'm happy to answer any questions that you might have. Thank you very much.
Thank you, Philip. This was very interesting. Both, I mean, the introduction to AI, but also the overview of the European landscape in AI I found it awfully interesting. Michael, you were supposed to moderate questions, but I don't see any questions coming in. It's very disappointing because this was an awfully interesting talk. So, Michael,
yes.
did you have questions of your own, maybe? To get,
yes,
to get the ball
of
rolling.
Course. No, first, I hope you can hear me. First of all, thank you very much, Philip. This was great. I have to admit that I learned a lot about AI now, about the scope. I was always in my mind making a simple connection between AI. Oh yeah, this is machine learning, this is deep learning, right? And I didn't think about all the other areas. So stupid me, I now have a better idea. Let me ask you two questions.
You're not alone, let me say.
Okay. Two questions. One is, when you go back to, or maybe you cannot go back, but in the beginning of your presentation, you talked about the areas of your personal interest. And I think there was trust mentioned in one of the circles. And can you elaborate a little more on this? I mean, you showed the example with the kid and the car, and trustworthy or trustful driving might be an example. But I have another example that is mentioned very often also by cybersecurity guys: trust in information. Can we trust information we are getting? And I think there's a lot of research going on there. Is there what is the connection between AI and helping a trustful, let's say, sourcing of information and interpretation of information?
Yeah, absolutely. And I mean, that is one of the areas that there's a lot of work in AI is about identifying, for instance, is there bias in the data? Right? I mean, the problem is a little bit, we don't know about anything which we don't have data about, right? We cannot. By just looking at the data. So, right, whether certain information is not even in the data set that you're using, we have a hard time knowing this from data analytics, for example, because the data analytics just looks at the data that is available. What we're doing, and there's a lot of research in this, I'm just coming out of a meeting where we had discussed exactly that. One of the big areas people are looking into now is how to use models. Models about how we understand how the world works. This could be differential equations in physics, could be whatever kind of models, and combine this with data. And those models, we can either come up with those models by hand, but on many cases we're actually also at least learning certain aspects of those models. And so I think that's where a lot of the trust will come from, is that we actually understand what is in the data. So also making sense of what is in the data, mapping these AI networks and other representations into something that we can understand as humans. So this explainable AI is really critical for allowing us to explain what the AI is doing, and through guarantees, which was one of the key elements I mentioned, right? If we can guarantee, so we can show this AI system works, but maybe only until there, and beyond that, right, we cannot guarantee anything. That is absolutely critical, because right now we don't know, right? The AI system in many cases just gives an answer, and it might be correct. In most cases, it maybe is correct, but it gives the same confidence answer if the input data is maybe outside of its range. And that's very dangerous, and we need to work on this. And really, I see this as one of the key elements that Europe can contribute. We have a strong background, and also a strong motivation to drive this forward. And one of the areas we're working on is, as I mentioned, is trusted AI. Really, this idea of providing guarantees about what AI can and maybe cannot do, but at least know what it can do.
So basically, telling us that in the future we can rely on AI to tell us which of the news we're getting on a daily fashion in social networks is fake news, and which might be a true origin.
Well, that's the problem, right? Is we can use AI to generate fake news. I mean, one of my colleagues actually in the next building over is doing the research that is, what's it called? The deep fakes, right? To generate synthetically generated faces and characters that mimic something, right? You can make Obama or Trump say whatever you want him to say. So we can use AI to generate the wrong things. Right? We typically use this for good purposes, right? But it can be used for bad purposes. But we can use AI also to identify where these deep fakes or other technologies have been implemented and or have been deployed, and to identify those cases. Of course, again, this is an arms race going on, but I think we see this in many, sides.
So
we have a question that came in. Two questions actually. So Philippe, you can see them in the question pane, but I can maybe read out the first one.
Yeah, I don't see them. I'm not sure where I have to click. Yeah, but if
It's
you could
in
just.
question. I will read it out. So first question from Christophe Prudhomme. Thank you for the nice presentation. How is the Claire community divided in terms of disciplines? Computer science, mathematics, others from application domains?
So currently we have these advisory groups for different parts of AI. So we don't have computer science or such or mathematics as separate groups there. But for instance, we have groups on machine learning. We have groups on computer vision. We have groups on deep learning and many other areas. We have started to form special interest groups. We have one for space, for example. So that would be more on the application side. So yes, we're starting to form those. For instance, we've also started a task force looking at COVID, right? And that's a very cross-disciplinary approach that we've brought together people from the entire AI community. But a lot of that are what you've just asked for, like sector-based, application-based, interdisciplinary or sub-communities. To some degree, they form in our social media environment, but we also are looking into setting them up in a more formal area where those groups get large enough. This is an area where we're only recently started to strongly bring this forward. There's certainly a lot of space still to do things there, and we welcome people who want to contribute. Our biggest limitation really is time to actually do all the great work we would like to do, and we already thought about, but we simply often cannot do it because the resources are too small, mostly in time and people.
Okay, so there is another question also from Christophe Prudhomme. There is a lot of work in the math community on dimensionality reduction, that is parameter reduction, working from different angles. How do you connect with this kind of work?
Oh, there's a lot of connections there. For instance, a lot of the auto-encoding work, for instance, essentially does dimensionality reduction by training a network to compress a certain domain of data into a compact representation, and then being able to essentially uncompress this to the original data again. So that's well-known technology. One of the areas where there's people do quite a bit of work there is currently how can we actually make sense of that compressed representation in terms of human semantics, right? These compressed, these latent spaces typically have no structure that makes necessarily sense for us as humans, and some of the work is about how can we project this. Essentially, it's a coordinate transformation such that we project it into a coordinate space where the basis vectors are concepts that we as humans know about. And we don't really know how to do this. This is an active area of research where, I mean, there's some techniques that go in this direction, but a lot more work is needed there. We don't really have a solution there.
There's one more question that came in from Sabri Plana. Let me read this to you, Philip.
Yeah.
Question for Philip. Regarding autonomous vehicles, could you highlight any ongoing R&D activities that involve industry, BMW, Volkswagen, and so forth?
Yeah. Yeah, so there's actually quite a bit of work going on there. In Germany, there is a large initiative funded by the federal government called the VDA Leitinitiative. The VDA is the Association of the Automotive Manufacturers, and there is a number of projects, I forgot 4 or 5 projects with dozens of partners each that many of them look into verification and validation techniques, look into I'm missing the word right now, but yeah, so there is a lot of that involves research in autonomous driving, specifically also in the direction of what I mentioned here. So using simulation for generating synthetic data is one part of that work. We as DFTI have also a number of projects with various OEMs, but also supply industry. So as you might have noticed at the very beginning of my talk, we have Daimler, ZF, we have BMW and Volkswagen as shareholders of DFTI. So we interact with them very closely.
Mm-hmm. And there's one more.
And I should mention in the context of Claire, just because this was a lot about Claire, so in the European ICT48 networks, we also have the car industry part of that. Mm-hmm. Only two representatives, Volkswagen and ZF. But one of the first theme development workshops will actually address the car industry, and so we'll invite not just those two companies, but actually the entire sector.
And maybe one last question. So thank you for the presentation. I was wondering if there is any possibility for early stage researchers to be directly involved in Claire.
Absolutely. I mean, Claire is really covering the entire research area from fundamental research to applied research. We have all groups or members from the Max Planck Institutes, for example. DFTI is more on the applied side. All things in between are part of this. So if you want to be involved in some way, just sign up as a supporter. Or even sign up as a member with your lab. And we, for instance, one of the things we regularly do is if there's a call specifically addresses AI in some way, then we write letters of support from Claire for projects under certain conditions, of course. We often help consortia to form and maybe help matchmaking between industry and research in this area. Like you need more industry partners for a certain proposal. So we're trying to do more and more of that. Again, it's to some degree it's limited by what we can do given the time that we have. But as I said, we have a number of offices across Europe, and so there's quite a bit of support already that helps us doing this. Kind of more strong closing organizing this. Yeah. Thank you very much.
So, well, we've covered all the questions we received. Michael, did you want to have a last word?
Well, last word should be with Philip. So thank you very much, Philip. To this initiative, Trans-Continuum Initiative, we stay connected. And I'm very sure that in the future, we're going to have other webinars touching maybe not so specifically on Claire per se, but on the interwoven fashion of workflows between AI, between big data, high performance computing, cyber physical systems, and all the good things that we focus on in this Trans-Continuum Initiative. So thank you very much, Philip.
Yeah, and thank you again for allowing me to present this here. And again, I see HPC and AI to move more and more closely together because we need lots and lots of high performance computing expertise to do a lot of the stuff in AI. And we also see a lot of capabilities of using AI to improve high performance computing technologies. So yep. I think it's a marriage made in heaven, if you
all right.
Thank you. Thank you, Philip.
Thank you very much.
Thank you to all presenters.
Nice day,
Thank you to our audience. Thank you for your questions. And we hope to see you in January. I don't have a date yet, but we'll have another ETP4HPC webinar in January. So once you leave today's webinar, you will receive a survey, and we would appreciate if you could complete it to help us prepare our next webinars, and you will also receive a follow-up email with a link to view the replay of today's webinar. So on behalf of ETP4HPC and our presenters, thank you for being with us today. We wish you all a happy but safe holiday season. Bye-bye.
Bye-bye.
Bye-bye. Thank you.
Bye. Bye.